Hello out there, welcome to this tutorial on JAMB past questions and solutions. We'll be looking at Mathematics 2022. This is brought to you by Oninab Resources. So we start with the first problem. Problem 1. If A is equal to a matrix of order 3 by 2 and B is a matrix of order 2 by 2, that's a square matrix of order 2, find AB. We are to find the product of A and B. In our solution, we have to first find if they are conformable for multiplication. To do that, we are going to state the order of each of the matrices in the order of their multiplication. So the first matrix is A, which is 1, 2, 3, 3 rows, 1, 2, and 2 columns. That's going to give us 3 by 2 matrix. And B is a square matrix of order 2. That's 2 by 2 matrix. So to verify for their conformability, the two numbers here, which is 2, 2, since they are equal, therefore the matrices are conformable for multiplication. So the resulting matrix is going to be 3 by 2, which is in the same order with A. So to carry out the multiplication, we bring in A multiplying B. We said it's going to be in the same order like A. So we have it. This is first element, second element, first, second in the third row. So we are going to fill in this. By matrix multiplication, it is the row multiplied by column. That is the row of the first matrix multiplied by the column of the second matrix. So we pick the first row, we then use it to multiply the first column here. We do that using the corresponding element. 2 times 3 giving us 6. 1 times 4 gives 4. So we add 6 plus 4. So we are done with first column. We then go to the second column, still maintaining the first row. 2 times 2 gives 4. 1 times 2 gives 2. So we have 4 plus 2. We are done with the first row. We then go to the second row. In the same way, we pick the first column. 2 times 3 gives 6. 3 times 4 gives 12. Then go to the second column. 2 times 2 gives 4. And 3 times 2 gives 6. So we have 4 plus 6. We are done with that. Then the last row, then we pick the first column here. 1 times 3 gives 3. 2 times 4 gives 8. So 3 plus 8. We go to the second column. 1 times 2 gives 2. And 2 times 2 gives 4. So we then simplify to get the entries of the resulting matrix. So we have 6 plus 4 gives 10. 4 plus 2 gives 6. 6 plus 12 gives 18. 4 plus 6 gives 10. 3 plus 8 gives 11. And 2 plus 4 gives 6. So this is the product of the matrices A and B. And the correct option there is option D. So we can see that. And that's the end of solution to problem 1. We then go to problem 2. For problem 2, evaluate n squared plus 1 combines n plus 5 if n is equal to 3. This is combination. So in our solution, we are going to substitute n equal to 3 so that n squared, when n is 3, that's going to give us 9 plus 1 gives 10. So we have 10 combines 3 plus 5, 8. So this 10 combine 8 by general definition of combination. N combined r is n factorial over n minus r factorial. So we can also get this from our calculator, but the expansion here is going to give us 10 factorial over 10 minus 8 factorial, then 8 factorial. That's going to give us 10 factorial over 2 factorial then 8 factorial. Remember, you can simplify from your calculator, but by expansion, this means 10 times 9 then times 8 factorial, since I have 8 factorial at the denominator, and 2 factorial is 2 times 1 then times 8 factorial. So the 8 factorial cancels the 8 factorial here, 2 here 1, 2 here 5, then we have 5 times 9 giving us 45 as the solution from the evaluation of this combination when n is 3, and that gives option B. So we are done with problem 2. We then go to problem 3. For problem 3, find x if the mean of 2x, 4x, 2x minus 13, and 6x is 4. So by mean, we are adding the whole of this and divide it by 1, 2, 3, 4. We divide by 4, so that in our solution now we have 2x plus 4x plus 2x minus 13 plus 6x divided by 4 is equal to 4. It is not because of this 4, because we have 4 items, 1, 2, 3, 4. That's why we are dividing by this 4. It is not because of this 4, because this 4 is the mean. So adding up 6, 8, and then we have 14x minus 13 over 4 is equal to 4. We cross multiply. 14x minus 13 is equal to 16. We take this 8, we take minus 13 to the right hand side. We have 14x is equal to 16 plus 13, giving 14x equal to 29. Dividing both sides by 14, x is equal to 29 divided by 14, and that gives 2.0714. And the closest answer in the option is 2.0, which is option B. And that's all for problem 3. We then go to problem 4. For problem 4, calculate the median of 14, 17, 10, 13, 18, and 10. So what we do to find solution to the median is to arrange either in ascending order or descending order. In ascending order means from the lowest number to the highest number, while in descending order, we arrange from the highest to the lowest. So anyone can come. So we are starting from the lowest, which is 10. So we record the 10. The next one is another 10. So we have the 10. The next is 13. We have 13. We then have 14. 14. We then have 17. So we record 17. And finally, we have 18 recorded. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if you divide these into 2, we group them into 2, we discover that these two numbers are in the middle, since we are looking for median. So after arranging it in ascending order or descending order, we pick the middle number. So this particular set of data, we have two numbers in the middle. So to get the median, we add the two numbers and then divide the sum by 2, and that will give us 13.5, and that is option B for problem 4. And that's all for problem 4. We then go to problem 5. For problem 5, solve for k in the equation 1 over 8 power k plus 2 is equal to 1. So to find solution to this, we are going to write this in index form. 1 over 8 is 8 raised to the power negative 1, then power k plus 2. 1 can also be written as index form of 8, since any number to power 0 is 1. So we have it equal to 8 raised to power 0. Then we expand the bracket up here, applying the law of indices. This negative 1 is going to be used to multiply everything outside the bracket. So we have 8 raised to the power negative k minus 2. Since negative 1 times k gives negative k, negative 1 times positive 2 gives negative 2 is equal to 8 to the power 0. Since the bases are equal, this is 8, 8, so the indices are equal. We then have negative k minus 2 is equal to 0. If you solve this, our k is equal to negative 2. Take this to the other side, divide both sides by negative 1, we have k to be negative 2, and that gives option C. That's all for problem 5. We then go to problem 6. For problem 6, evaluate 101 base 2 power 3. This is a case of expanding. That is 101 base 2 power 3 is equal to 101 base 2 times 101 base 2 times 101 base 2. We're going to take them 2 at a time. So we multiply in base 2 directly. This is easier. You have the option of converting them to base 10, then simplify, convert back to base 2. That would be too long and time consuming. So this is better. So 1 times 1 gives 1. 1 times 0 gives 0. 1 times 1 gives 1. I then pick the 0. 0 times 1, 0. 0 times 0, 0. 0 times 1, 0. Then I pick this one again as my multiplier. 1 times 1 gives 1. It is recorded under the 1. 1 times 0, 0. 1 times 1 gives 1. We then add them up. So this is going to give us 1. This is 0. 1 plus 1 is 2. We can't have 2 as a digit in base 2. So what we'll do is to divide the 2 by 2. Take the quotient and the remainder. So it goes 1 time, remainder 0. We are writing down the 0 and carry the quotient. That is the number of time it goes, which is 1. We add that 1 to this 0 to give us 1. Then we have 1. So this is for the product of the first 2. Then we now multiply by 101 base 2. In the same way, we carry out the multiplication. 1 times 1, 1. 1 times 0, 0. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. Then this 0 multiplying the whole. This is going to give us 0, 0, 0, 0, and 0. We pick this one to multiply again. 1 times 1, 1. It comes under the 1. That is under the multiplier. 1 times 0, 0. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. And then finally we add. So in our addition, this is 1. This is going to be 0. Here is 1. Here is also 1. 1, because we are just adding 1 to 0, 0. So this is 1 and 1 base 2. So this is our final answer. 1, 2, 3, 4, 5, 0, 1. This is 4. This is 6. So our option is option C for problem 6. We then go to problem 7. For problem 7, if a fair coin is tossed twice, what is the probability of obtaining at least one head? One head. We need to get the sample space for our solution. So the sample space is going to be head, head. Then we have a tail, tail, head, tail, and what? Tail, head. So there are 4 possibilities. And the question is asking the probability of obtaining at least one head. So what we do is to look for where there is 1 or 2 heads. There are 2 heads here, 1, 1, which is 3 out of 4. So the probability of having head greater than or equal to 1 is going to be 3 over 4. 3 over 4 in decimal is 0.75, and that gives option B. So that's all for problem 7. We then go to problem 8. For problem 8, given that the mean of 2, 5, x plus 1, x plus 2, 7, and 9 is 6, find the median. We're going to use the mean given to find the value of x. From there, we will be able to find the median of the data. So we start the solution. 2 plus 5 plus x plus 1 plus x plus 2 plus 7 plus 9 divide by how many numbers do we have there? 1, 2, 3, 4, 5, 6. So divide by 6 is equal to 6. This is the sum of the numbers. Divide by the number of items is equal to 6, which is the mean. So we simplify. 7, 8, 10, 17, 26 plus 2x, that's x plus x, plus 2x, then we cross multiply is equal to 36, 6 times 6. We then take this to the other side. 2x is equal to 36 minus 26. 2x is equal to 10. Dividing both sides by 2, x is equal to 5. So since x is equal to 5, which means the number we have here is going to be 6. This one will be 7, 7, and 9. So this is not part because that's the mean. If you look at it, the number has been arranged in ascending order. So we have 2, 5, 6, 7, 7, and 9. And there are 3 to this side, 3 to the other side. So the middle numbers are 6 and 7. So that to find the median, we just add 6 plus 7 divided by 2, and that gives 6.5, which gives option C. And that's all for problem 8. We then go to problem 9. For problem 9, if sine theta is equal to negative 3 over 5 and theta is in the third quadrant, find cos theta. So to find solution to this problem, we need to bring in the 4 quadrants. This is the first quadrant, the second, and the third quadrant. So the theta is here. We call this angle theta. This is theta. And if you look at this is negative side of x, negative side of y. So we can now create a right angle triangle here because this side from here to this side is equal. So sine theta is equal to negative 3 over 5. So this is by trigonometric ratio, SOHCAHTOA, opposite over hypotenuse. If you look at this opposite, this is opposite, and it is the one that is carrying the negative 3, and the hypotenuse is positive. So we know that 3, 4, 5 is a Pythagorean triple. Therefore, this side here is going to be negative 4, since this is the negative side of x. So from here, this right angle triangle, we can then find cos theta. Cos theta is adjacent over hypotenuse. Our adjacent is negative 4, and our hypotenuse still remains 5. So we have cos theta to be negative 4 over 5. And that gives option D. And that's all for problem 9. We then go to problem 10. For problem 10, simplify 1 over 3 minus root 2 in the form of p plus q root 2. So to find solution, we are going to rationalize 1 over 3 minus root 2. To rationalize is to multiply the numerator by the conjugate of the denominator. The conjugate is just to change this negative to positive. So we are going to have 1 times 3 plus root 2 over 3 plus root 2. Remember, 3 plus root 2 divided by 3 plus root 2 is 1. So the whole thing is just like multiplying the surd by 1. So we have not altered anything. So 1 times 3 plus root 2 will give us 3 plus root 2. And since these are conjugates of each other, what we do is just to multiply the corresponding element. So 3 times 3 gives 9, and minus root 2 times plus root 2 will give us a minus 2. So that our answer here is going to be 3 plus root 2 divided by 7. We can then split this fraction into 2. Splitting it, we are going to have 3 over 7 plus root 2 over 7. So that is the form we are to present our answer, and option D is the correct answer to problem 10. We then go to problem 11. For problem 11, find the length of a chord 3 centimeters from the center of a circle of radius 5 centimeters. So in our solution, we are going to draw the diagram, a circle, and we're told of a chord and the radius 5 centimeters, and the center is this. Since the chord is 3 centimeters from the center of the circle, so we join to this point, which is 3 centimeters. Remember, this is always 90, so this is point M, so that the chord will be AB. This is the midpoint of AB, so it means AM is equal to MB. So if we find MB now, we then multiply by 2 to give us our AB. So using Pythagoras theorem, since this is a right angle triangle, we have a MB squared is equal to 5 squared minus 3 squared, since we are looking for the other side other than the hypotenuse. So this is 25 minus 9, giving us 16. MB is square root of 16, which gives 4. So that our AB now, we said we are multiplying the MB by 2, since MB is equal to AM. So we have 4 times 2, giving us 8 centimeters. And that is option A. So that's all for problem 11. We then go to problem 12. For problem 12, Mr. Adu spends his annual salary on food, F, rent, R, car maintenance, C, gift, G, savings, S, and some miscellaneous, M, as indicated in the table below. So we have the percentages and the letters representing the items he spends his money on. So if the information on the table is represented on the pie chart, what angle represents his spending on food? So remember, in a pie chart, the total angle there is 360 degrees. So in our solution, so that the angle for food will be the percentage of food, which is 28 over 100 multiplied by 360 degrees, since we have established that the sum of angles in a pie chart is 360. So simplifying this, we have 100.8 degrees, which is option B. So that's all for problem 12. We then go to problem 13. For problem 13, a rectangular pyramid has an area of 24 squared centimeters and a height of 7.5 centimeters. Calculate the volume of the pyramid. The volume of the pyramid is going to be 1 over 3 area times height. Ordinarily, volume is base area times height, since the pyramid is 1/3 of the entire area. So we now have it as 1 over 3 area times height. And our area is 24. So 1 over 3 times 24 times 7.5. This is giving us 60 cubic centimeters. 60 cubic centimeters is option D. So that's all for problem 13. We then go to problem 14. For problem 14, the 10th term of an AP is 32. If the first term is 3 over 2, what is the fourth term? So this is an AP. What we do is we know that T10 is A plus 9D. We then substitute in our values, that is T10, which is 32, is equal to our A 3 over 2 plus 9D. We are looking for D. From there, we'll be able to get the fourth term. Multiplying through by 2, I have 64 is equal to 3 plus 9. Multiplying through by 2, I have 64 is equal to 3 plus 18D. I've multiplied each by 2. So 18D is equal to 60. So 18D is equal to 64 minus 3. 18D is equal to 61. So that D, which is the common difference, is 61 over 18. And from there, we find our fourth term. T4 is A plus 3D. So our A is 3 over 2 plus 3 times 61 over 18. 3 over 2 plus 61 over 6. Because 3 goes here 1, 3 goes into 18 is 6. LCM is in order to make this the same denominator, I multiply by 3, so that's going to give us 9 over 6 plus 61 over 6. We can just add directly since the denominators are now equal. So we have our answer as 70 over 6. In the simplest form, we have it as 35 over 3. 2 divides 70 to give 35. 2 divides 6 to give 3. So our option here is A. That's all for 14. We go to problem 15. In the diagram shown, angle LNM and angle YNZ are represented by G and H respectively. Find angle MNY. To find solution to this problem, we have to identify that LZ is a straight line. Since it's a straight line, this plus this plus this will give us 180. Therefore, to get our MNY, angle MNY is now going to be 180 minus G, then minus H. So that is option A. So that's all for problem 15. We then go to problem 16. For problem 16, in how many ways can the letters of zoology be arranged? This is permutation of indistinguishable objects. So to do that, we need to count how many letters are there in zoology. 1, 2, 3, 4, 5, 6, 7. So N is going to be 7. Then how many of the letters are repeated? So Z is now repeated. O is repeated 3 times. So we have O's to be equal to 3. L is 1, G is 1. The rest letters are 1, 1. So the number of ways now is going to be 7 factorial over 3 factorial. This is going to give us 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. So the 3 factorial will go with this 3 factorial. Multiplying out this, we have 840 ways of arranging the letters of the word zoology. And that gives option C. That's all for problem 16. We then go to problem 17. Find the integral of 2x plus 1 power 3. We are to integrate 2x plus 1 to the power of 3. So in our solution, we're going to integrate by algebraic substitution. So we have integral of 2x plus 1 power 3 dx. We let what we have inside the bracket to be u, which is u equal to 2x plus 1. We then differentiate u with respect to x. So du, the x is equal to 2. So the derivative of a constant is 0. We then make the x the subject of the formula so that we substitute here. So we now have the x is equal to du over 2. So in our solution now, the integral of 2x plus 1 power 3 dx, we substitute all these. 2x plus 1 is u, so we are going to have it as integral of u raised to power 3. The x is what? Du over 2. So this is a constant, so we have it as 1 over 2 integral of u raised to power 3 du. Integrating u raised to power 3, I have 1 over 2 times u raised to power 4 by 4, then plus c, that is the constant of integration. Substituting back the value of u, we can multiply this 1 over 2 times 1 over 4, giving us 1 over 8 into 2x plus 1 raised to power 4. Since our u is 2x plus 1, then plus c. So we can also write it as 2x plus 1 power 4 over 8. 2x, wow, the option is B. And that's all for problem 17. We then go to problem 18. For problem 18, make V the subject of the formula from R equal to square root of 3V over pi h. So to find solution to this problem, to remove this square root, we square both sides. So we now have R squared is equal to 3V over pi h. We then cross multiply. 3V is equal to pi R squared h. Dividing both sides by 3. V is pi R squared h divided by 3. Pi R squared h divided by 3. This one does not have square, so the option is C. We then go to problem 19. Find the determinant of the matrix A equal to 2, 3, 1, 3. So the determinant is written as absolute value of A, or we can change the brackets to a straight line. So to do that is just to cross multiply and find the difference. So 2 times 3 giving us a 6 minus 1 times 3, that's going to give us a 3. 6 minus 3 gives a 3. So that the determinant of A is 3, and that gives option D. So we go for problem 20. Evaluate log to base 2 A to root 2. So we are going to make this a single surd. 8 is square root of 64. So log to base 2 square root of 64 times square root of 2. Applying law of surds, we multiply out. So log to base 2, 2 times 64. This is log to base 2 root 128. We can write square root of 128 in index form completely, since 128 is 2 raised to power 7. The square root is power half. So we have log to base 2, 2 raised to power 7 power half. Applying law of indices, we multiply out this. So we have log 2 raised to power 7 over 2 base 2. Applying law of logarithms, this power will come down. It becomes 7 over 2 log 2 base 2. Log 2 base 2 is 1. So our final answer is 7 over 2, which is 3.5. And that gives option C. So that's all for problem 20. We then go to problem 21. For problem 21, the locus of points equidistant from a fixed point is, so let's look at it. You have a fixed point and then you have locus equidistant from this fixed point. That's the definition of a circle. Definition of a circle. So the correct option there is A. Then we go to problem 22. For problem 22, find the result when the numerator of 96 over 50 is decreased by 37.5% and its denominator decreased by 20%. So in our solution, we look at the original numerator, which is 96, then the new or the decreased numerator now. Since this is 100, the numerator will be taken as 100. The decreased numerator is going to be 100 minus 37.5. We still have the option of calculating 37.5, then subtract it from 96. But it's more direct than to take 37.5 away from 100. What we have is going to give us 62.5% of 96. So we then simplify, that's giving us 60. Then the original denominator is 50, and since it is decreased by 20%, so the decreased numerator now is going to be 80% times 50, and this gives 40. So the new fraction now becomes 60 over 40. So 60 over 40 is going to be simplified further, and that's going to give us 3 over 2. 3 over 2 is 1.5. So we have the correct option there as A. That's all for problem 22. We then go to problem 23. If a poultry farmer realized 200 eggs from his birds and sold 5.5 crates of eggs, what percentage of eggs are left? So in our solution, the number of eggs realized is 200 eggs. The number of eggs sold is 5.5 crates. So we now look at 5.5 crates of eggs, which is going to be 5.5 times 30. A crate is 30 eggs. So that's giving us 165 eggs. Number of eggs left is going to be 200 minus 165, and that gives 35. So the percentage of eggs that is left, that's going to give us 35 over 200 times 100%, and this gives 17.5. 17.5 is option C. And that's all for problem 23. We then go to 24. Given sec squared theta plus tan squared theta is equal to 3, find the angle theta. So to find solution to this, we need to consider an identity or set of identities. So this, we should be familiar with this identity. Sin squared theta plus cos squared theta is equal to 1. 1 plus cot squared theta is equal to cosec squared theta. Tan squared theta plus 1 is equal to sec squared theta. So we look at these three identities. Which one are we going to substitute to enable us simplify and get the value of theta? The third trigonometric identity will fit in here, so that we now have 1 plus tan squared theta representing sec squared theta, since sec squared theta is 1 plus tan squared theta. So we replace sec squared theta with 1 plus tan squared theta, then plus tan squared theta is equal to 3. Taking this to the other side and simplifying further, we have 2 tan square theta is equal to 3 minus 1, which gives 2. Dividing both sides by 2, tan square theta is equal to 1. We have to find the square root of both sides. So square root of tan square theta is tan theta, and square root of 1 is equal to 1. So theta is tan inverse of 1. And from our special angles, theta is equal to 45 degrees. And that gives option C, because tan 45 degrees is equal to 1. Therefore, theta is equal to 45 degrees. And that's all for problem 24. We then go to 25. Find the limit of y equal to x3 plus 6x minus 7 over x minus 1 as x tends to 1. You see, if we substitute directly the value of x equal to 1, this is 1 plus 6, 7 minus 7, 0 over 0, which is undefined. So we now find a way of factoring the numerator. So from here now, it is very evident that x minus 1 is a factor of x3 plus 6x minus 7. So to get the second factor, we have to go by long division. Here is x minus 1, then the numerator is x3 plus 6x minus 7. When we do long division, our concentration is always on the first term. So x3 divided by x will give us x squared. We then use this x squared to multiply the divisor. Remember, in the process of division, we don't have business with the second number. It's just always the first term. So x squared times x gives x3. Then x squared times negative 1 gives negative x squared. We then subtract. So x3 minus x3 is gone. And this one has 0x squared minus x squared, giving us x squared. We then bring down the 6x minus 7. So again, we concentrate on this x squared and this x. So x squared divided by x gives x. So we have plus x. So we then use this plus x to multiply everything within the divisor. So x times x gives x squared. X times negative 1 gives negative x. So we subtract again. X squared minus x squared is gone. 6x minus negative x will give us 7x. We then bring down the 7. So again, we look at the first term here and the first term. 7x divided by x gives 7. So we have plus 7. We then use the 7 to multiply the divisor. So 7 times x gives 7x. 7 times negative 1 gives negative 7. So that if you subtract now, our answer or the remainder is going to be 0. So we can now say that x minus 1 multiplying this second factor to give this. So we have x minus 1 into x squared plus x plus 7 divided by x minus 1. So this x minus 1 goes with this x minus 1. We are then left with x squared plus x plus 7. So the limit now as x tends to 1 is just to substitute x is equal to 1. So that's 1 squared plus 1 plus 7, which gives 9. And that's option A. And that's the end of solution to problem 25. We then go to 26. For 26, find the equation of a straight line parallel to line 2x minus y is equal to 5 and having intercept of 5. And the intercept of that 5 is going to be intercept on y-axis. In order to avoid ambiguity or confusion, because there are two intercepts of a straight line, there is x-intercept, there is y-intercept. So the y-intercept is not stated here, but by implication, they are referring to y-intercept. But they should not presume that everyone will know, oh, it is y-intercept. They have to be specific. Yeah, they need to be specific, because it's a different thing if the intercept is on x-axis. So that's why they have to be specific. So we're going to make y the subject of the relation so that it will look like the standard form of linear equation y equal to mx plus c, where m is the gradient and c is the intercept on y-axis. Not just intercept, it is intercept on y-axis. So we then have it as y equal to, if I take this to this side, 2x minus 5. So in this case, our m1 is equal to 2. This m1 is still the same thing as m2 since they are parallel. So the two lines are parallel. So we then get to find the equation of the new line. So that's going to give us y is equal to 2x then plus 5, since the intercept c on y-axis is 5. So that's that. And we are to make it in this form: 2x plus y, x, y then equal to the constant. So it's as good as taking this to this side and bringing this to this side, giving us 2x minus y is equal to negative 5. 2x minus y is equal to negative 5. That gives option C. So we are done with problem 26. We then go to problem 27. Find the equivalence of 10,110.011 base 2 in base 10. So we have to convert this base 2. We call it decimal number. The one with point is decimal number. So in our solution, we are going to split this into two, the whole number part and the decimal part. Immediately after the decimal point, we start numbering from 0, 1, 2, 3, 4. Then after the decimal point, our numbering is going to be negative 1, negative 2, and negative 3. So that we now pick the 1 times the base 2 raised to power 4, then plus 0 times 2 raised to power 3, plus 1 times 2 raised to power 2, then plus 1 times 2 raised to power 1, plus 0 times 2 raised to power 0, plus 0 times 2 raised to power negative 1, plus 1 times 2 raised to power negative 2, and plus 1 times 2 raised to power negative 3. So 1 times 2 raised to power 4 is 16. Then plus 0 times 2 raised to power 3 is 0. Plus 1 times 2 raised to power 4 is 4. Plus 1 times 2 raised to power 1 is 2. 0 times 2 raised to power 0 is 0. Plus 0 again. Then this is 1 times 2 raised to power 2. That's giving us 1 over 4. That's giving us 0.25. Then plus, this is going to give us 1 over 8, which is 0.125. So adding up this, we have our answer as 22.375. 22.375 gives option D. And that's all for problem 27. We then go to 28. Problem 28. Given that the cost C of running a school is directly proportional to the number of students N, if 20 students cost 10,000 naira, how many students can 1 million naira cover? This direct proportion, so C is directly proportional to N, where C is equal to Kn. And we are told that when C is 10,000, N is 20, so 10,000 is equal to 20K. Dividing both sides by 20, that's going to give us 500. K is 500, so C is equal to 500N. It means each student can be fed with 500 naira. Now we are to calculate how many students can be fed with 1 million naira. That is when the cost is 1 million, then we have it to be equal to 5n. So n is 1 million divided by 500, and that gives 2000. That's 2000 students. It means with 1 million naira, 2000 students will be fed. That's option C. So we go to problem 29. The coordinates of the midpoint of the line joining points -3, 5 and 2, 10 is given by, to find the midpoint, we have x1 plus x2 over 2, y1 plus y2 over 2. If this is x1, y1, x2, y2, we plug in these into the formula. So that's going to give us -3 plus 2, then divide by 2, comma, 5 plus 10 divided by 2. -3 plus 2 gives -1 over 2, then comma, 5 plus 10 gives 15 over 2. We then look for the option containing this. No, so it's option D. So the correct option to problem 20 is D. That's all for problem 29. We go to problem 30. Given that s is equal to ut squared plus 5t minus 10 is the displacement of a particle in meters, calculate its initial velocity. We're going to look at initial velocity, the time is 0. So this is the distance or displacement given. Velocity is the rate of change of displacement with time. So it's a function of time. So in our solution, we have the displacement to be s equal to 3t squared plus 5t minus 10. So remember, velocity, which is v, is the s, the t. Differentiating this, that's going to give us 6t then plus 5. So at initial velocity, t is equal to 0. So our velocity will be 6 into 0 plus 5, which gives the velocity to be 5 meters per second. 5 meters per second, that's option C. Then we go to problem 31. Problem 31, in the diagram shown, xy is 8 centimeters and ox is 5 centimeters. Find OZ. OZ, that's the distance of the chord from the center of the circle. That's x. What we do is, since xy is 8 centimeters, xz is going to be 4 centimeters, and then zy is going to be 4 centimeters too. So, and this is right angle triangle. We are going to use Pythagoras theorem to get the value of x, which is going to be 3. So OZ squared is equal to 5 squared minus 4 squared. That will give us 9. OZ is equal to square root of 9, which gives 3. And then option D, which is 3 centimeters, is OZ. That's all for problem 31. We then go to problem 32. Problem 32. Let asterisk be a binary operation on a natural number defined by a operation b is equal to a minus b plus ab squared. Then find 3 operation 5 or 3 asterisk 5. So in our solution, we are going to take 3 to be a and 5 to be b. We substitute into this relation. That's going to be 3 minus 5 plus 3 times 5 squared. 3 minus 5 is -2 plus 225, because 3 times 5 is 15. 15 squared is 225. So -2 plus 225 gives 223. 223 is option A. And that's the end of solution to problem 32. We then go to problem 33. If y varies inversely as x and x is equal to 3 when y is 4, find the value of x when y is 12. So this is inverse variation. Y varies inversely. That's going to be 1 over x. So that y is equal to k over x. We can then have it as k is equal to xy. So our k is going to be 3 times 4, which gives 12. So we then go back to substitute here to get the relationship between x and y. That's going to give us 12 over x. And when y is 12, so 12 is equal to 12 over x. We have to find x when y is 12. So it is very obvious here now that since 12 is equal to 12 over x, it means x is equal to 1, because 12 over 1 is still giving us 12. And that gives option B. And that's the end of solution to problem 33. We then go to problem 34. For problem 34, if 8, PQ, and 26 is an AP, find the values of P and Q. So we are told that A is 8, and the second term, third term, fourth term, T4, which is A plus 3D, is 26 equal to 8 plus 3D, and 3D is equal to 26 minus 8. 3D is equal to 18. D is equal to 6. Since the common difference is 6 and the first term is known, we can then calculate the second term, which is P, to be, since it's an AP, is going to be the first term 8 plus the common difference, and that gives 14. We can also use the value of P to get Q. So our Q is just to add 6 again to P. That's going to give us 14 plus 6, which gives 20. So we have it as D, since P is equal to 14 and Q is equal to 20. And that's all for problem 34. We then go to problem 35. Problem 35, factorize 4a squared minus 9b squared. So in our solution, we have to look at 4a squared minus 9b squared as difference of two squares, because 4a squared is a perfect square, 9b squared is a perfect square. So what we do is square root of 4a squared is 2a, then we join the square root of this one with plus, that's plus 3b in bracket. The second factor is still the same thing as 2a minus 3b. That's all for that. So we go to the option 2a minus 3b, 2a plus 3b. So option A is the correct option in problem 35. So that's the end of solution to problem 35. We then go to 36. If n of p, that's the number in set P, is 20, n of q is 30, and n of p union q is equal to 40, find the value of n of p intersection q. So we have the solution. We know a relationship that exists among the four sets, that is n of p union q is equal to n of p plus n of q minus n of p intersection q. Since we are looking for n of p intersection q, we move this n of p intersection q to this side, so that this n of p plus n of q will still remain on the right hand side. Where n of p union q goes to the right hand side, it becomes minus. So substituting in these values, n of p is equal to 20, so we have 20 plus n of q, which is 30, then minus 40. So simplifying this, n of p intersection q is equal to 10, and that is option A. That's all for problem 36. We then go to 37. Problem 37, 3 times a certain number x minus 2 is less than the number minus 6. Find the possible values of x. So what we do is we form the linear inequality. 3 times a certain number, that is 3 times x minus 2 is less than the number which is x minus 6. So this is it. We multiply out 3x minus 2 less than x minus 6. So solving this inequality, we move this x to the left hand side. We have a 3x minus x is less than, we move this negative 2 to the right hand side. It becomes 2 then minus 6. 3x minus x gives 2x. 2 minus 6 gives negative 4. So we have 2x less than negative 4. Dividing both sides by 2, x is less than negative 2. And that is going to give us option A. That's all for problem 37. We then go to problem 38. The number line is represented by inequality. So which of the inequality is represented here? So what we'll do is, since we have x here, it means x, and the arrow is pointing to the right, that's going to be greater than 2, being starting from 2. And since this circle here is not shaded, so it is just greater than. Has it been it is shaded, it will be greater than or equal to. So from the option, we have option D as the correct option. So that's all for 38. We then go to 39. Question 39. If a dress is sold for 3,800 naira at a 20% discount, what is its original price? To find solution to this, there's a discount, which means this amount is not up to 100%. So what we'll do is to say 100 minus 20 to give us 80%, which means 3,800 is equal to 80%. And the original price is always 100%, which means P naught is equal to 100%. If we make P the subject of the relation, it is going to be 3,800 times 100, then divide by 80. So you press your calculator, we have the original price to be 4,750 naira only. And that's all for problem 39. We then go to problem 40. Problem 40, we have a Venn diagram. The shaded portion in the Venn diagram above represents, so we need to identify what the shaded portion represents. Since if you look at this, the whole of set E and G, meaning there are no elements there. So if you cover it, it means E complement. Cover this one, it means G complement. So what it means now is we have removed E completely, we have removed G completely. What we are left with is F only. So we have it as E complement intersection F intersection G complement, which means F only, and that gives option B. So the answer is option B. And this is the end of solution to this tutorial. I hope you enjoyed it. Thank you for watching. Please like and share. Until we come your way again, goodbye.